Okay, so here's what we're going to do. We're going to do a video on a 2000 Dakota. We'll copy this, which is a 403AF controller. It's the latest revision. And we are going to show you in an SCT some of the basic starting stuff. So here we go. Let's load factory calibration for this. So basically, if you've got Advantage software, you can do the same thing here. It's going to bring up your stock tables, and what we're going to do here, you can save it, and you want to save and create a folder because you have a lot of changes and stuff like that, and you want to save them by date and revisions. That way, you know what to go back to. But let's go through this standard 2000 Dakota RT here. So first thing I'm going to do is there's a lot of these things that are not going to be used on here. There's going to be just some very minor changes that we're going to make that's going to make the big difference. But let's first take a look at the factory spark curve. So on your factory spark curve, you can see that this RPM right here, wide open throttle is here, 787. You got to put your engineering hat on and start thinking in torr instead of vacuum. So think of this as zero vacuum. And think of this as negative 30 inches of vacuum, very high. So basically I'm idling here. Well, in a factory truck, I'm idling here, right? So everybody always asks me, why does the timing bounce around when I'm reading it on my scanner? There you go. You can see it's bouncing around based upon this main table and also how much spark retard it's pulling out at certain temps. But anyway, going back to this. So when you get on it, you can see it goes to here and then starts climbing. So it sends you out of the hole with 5 to 7 degrees of timing. Then you get to 10, then you get to 12, then I get to 14, and finally 4,000 RPM, I'm starting to make 24 degrees of timing. Well, anybody that's ever raced anything in the past with their own distributor knows that that's nowhere where you want to be. So notice also there's no EGR obviously on a 2000 RT, but the tables are still there. So basically, I've said it many times in the past, I lock down my spark tables. So whatever I do in this table right here, I'm going to do the same, cut and paste into the other two tables, just so I don't have to look. So if for any reason it ever referenced that table, hardware failure in the PCM, whatever, it will go to what I commanded it to. So we're going to go over a couple little setups here to make this easy. So let's start with the normal stuff that everybody likes. Okay, so you can see your factory rev limiter at 5300, and the truck shuts off at 112. So basically, what we're going to do is we're going to do a Mopar Performance PCM and give the guy 150 miles per hour. That's more than safe. That's what I do on pretty much on all of mine. And then we're going to go to the shift lock schedule. It's the same as a Mopar PCM. It's going to be 53 to 5500. So I'm changing the minimum and the maximum watt target, and I'm also matching the watt shift target. So I'm making all of them match. So it always looks for that. Now, when you go out and you take the truck out and it shifts at 5300, and you know you're commanding 5500, this is where you adjust the TV cable on the throttle body, and this is, you will tighten it to raise the line pressure slightly and to match that value. So if you raise it and it shifts at 5800 or 6000, you've gone too far. So basically, you want to back off that TV cable until it matches what you're commanding it, and in this case 5500. So we've done a rev limiter or shift lock. So now let's go get rid of the annoying torque management. There it is. Stall torque enabled. Please, let's get rid of that. I'd like to do a burnout sometime today. So now I can do that. We're also going to go up here to our fuel. I take the delays and I turn these delays off. Some of these delays, before you go into wide open throttle tables, some of these are these timers here are set to expire at higher numbers, such as 20 seconds, or excuse me, 2.2 milliseconds. and I don't want that. So basically what I'm going to do is I'm going to turn my blend rates and my RPMs off for any of those. So let's take a look at the fuel table. This is milliseconds in the fuel table, same thing, 787, 111, there's your RPM, 4800, and yes, we can rescale this to read 6,000 RPM. So basically what happens is if you go to 5,000 RPM, it's just going to use this last table down here to go to those points, unless you rescale. So you can basically see I'm sending 16 milliseconds of fuel. I'm idling somewhere around 2 to 3 milliseconds of fuel right here. If I've got a cam, I'm running really rich. So basically what happens is when you put a cam in, you're going to have to you're going to be idling somewhere in this area down here, probably even here. Well, 600, yeah. It's going to be throwing anywhere between 5 and 9 seconds of milliseconds of fuel, which is too rich. So that's why when you get a camshaft, you have to take your tables right here, and you want to reduce them by roughly 10%. So I do that. So this is a little camshaft. Let's say that now we're going to be idling in 3, probably right around, well, we're going to, like a UTP 450 cam is going to pull 12 to 13 inches. So it's going to be right here, 2.9 to 3 milliseconds of fuel at 800 RPM. So basically I do the same thing on the EGR off tables. So I want to make them match. So basically I can do this. I can take this table, copy, Control C. I can go into my EGR on table and make them all match. Now see, some of them went red because now I'm just making both tables match. So let's go to the table here where we know we run rich from the factory. So from 3200R on, all of our trucks go pig rich. So basically you're going to pull about 10% of the fuel out right here. Now this is where you're going to adjust your wide open throttle. So let's say, for example, let me click back at it. Undo. Let's say 0.95. Let's just do a 5%. Okay, so now it's decreasing this multiplier, which, so if you remember on your other table here, like right now you got 16, and then you take your multiplier right there, 16 times 1.1, that's going to be the milliseconds it's going to command at wide open throttle. So basically when you're on the dyno and you're trying to target 12.8 air ratio for the best power pulling curve, you're going to adjust these tables here, not these tables back here. Don't mess with these. Use your multiplier to do your watt tables. Super easy, excellent way to get that done. So now that we've got pretty much, we're close to where we need to be for fuel for a start and a safe. Let's go down to the idle. We're going to take our Dashpot right here. We're going to just bring this down to about 4 on the Dashpot. So what this is doing is, you can actually zero these out too, but sometimes when you zero them out, you'll come to a stop and she'll want to die. So I usually leave them, I just decrease it by half. So basically what happens is it revs quick, comes right back down. It's very nice. It's a fast rev setup for your throttle body. It doesn't hold that IAC motor open all the time. So let's go down to idle speed drive. We're going to set this camshaft to 800 RPM, and on my neutral table I give it another 20 RPM over my drive. So basically when I'm in park, it's going to target 1800. When I'm in drive, it's target 1800. When you coast or you're in neutral, it's going to go to 816, and you can change that however you want. But typical for UTP 450 cam is that setup there. So here's another cool one that we can do on 2000s and more. Maybe not. Not on this one. So anytime you see negative 64s, you can't change your fans. Let's go back and find. Let's see. There's got to be a 2001 in here. Oops, am I going the right way? Yeah, there we go. 2001. Let's pull up this RT right here. Copy. Let's go back. I'm going to do a new. Let's see if it'll let us change the fans on this 2001. There you go. So those are actually controlled. So now, for example, on this guy, you can change this down to 85 Celsius, 82, 85. So now you can control the fans, and you can take the clutch fan off of the guy's setup right there and just run the electric fan. So now you're giving him some horsepower by getting rid of that heavy clutch fan and just controlling your fans from the factory. So that's pretty cool on that one right there. No, I don't want to save that. Wait, sorry, close. Yes, I do. I thought it asked me if I wanted to say blah blah blah. So anyway, back to where we're at. So let's go down and take a look at our off-road setup right here. Powertrain config 4. Here's my O2s. So see, I have a rear O2 sensor. So I'm going to disable that for my off-road configuration. You obviously don't do this on the street because if we all keep our catalytic converters on our trucks like we're supposed to, right? And if you go off-road, build an off-road truck, you still want to keep the O2 sensor plugged in, but you disable its use in the software here. You definitely want to keep your forward active because that's how we do our 14.7 mixture that it targets. So back to idle, we changed our idle speed, we're good there, we did our fuel, can't do anything. Coasting fuel shut off. If you do have problems with coasting fuel shut off, you can raise the timer, you can zero out the timer, and you can raise the shut off to 126 miles per hour and get that out of the way. And so that sometimes we have, especially on a 5-speed, you have basically a coasting situation where it idles super low, 400 or 500, until you get below 5 miles per hour, and then all of a sudden it comes back up. So when you come to a stop, then it comes back up. And that can be annoying, and that's based upon, because it's looking at that ABS sensor in the back. Well, in this software, it doesn't talk to anything ABS-wise, so I can't change that. So if you go back to the VSS sensor on your differential on the pumpkin, and you disconnect it, you'll lose your speedometer, but you'll notice that it idles at 800, where you've commanded it in the software, all the way to a stop. As soon as you plug that back in, get it back up, it idles low, killing your fuel, and then comes back up. So we try to minimize that with those two settings right there. So let's go down to, now that we've done the fuel, we've done the basic parts of this. And just so you know, speed density right here. Here are going to be the tables that you're going to change for 2-bar map sensor later on, which is actually going to be split table in here. It's not going to rescale the tables like it should properly, like in our, in the Diablo software for SRT4s and stuff. But for here, this would be the table where you would change your minimum map key on to 60 right there. Oops, sorry. Take your 120 to 60 right there for a 2-bar map, and then basically you would cut your zero vacuum would be here now. So these would all be boosted tables. So for example, you would want all those to be 16 degrees of timing right there, for example, with no intercooler. You can probably give it whatever, 22 like right to here, and maybe 20, 22. And then you can make these whatever 20 and then roll back to 16. Now watch this. You can also interpolate this. You can smooth it, and you have to click back out and go back to it to view the smoothing. And you can view that in the graph to see where it's pulled out timing as I roll up and into throttle here. So it makes a nice smooth transition. But we're not going to do that. So I'm going to go back to this file, reload that selected items. Now we're back to our crappy 24 degrees of timing. So now that we've corrected the fuel, turned off the torque management, changed our rev limiter, changed our shift points, and turned off a few things, let's go in here and play with the spark. Now look at your IAT. So your IAT at wide open throttle, when it gets up to 120 Celsius, it's pulling 3 degrees of timing. Now this is worse on V10s and Jeeps. You'll see that the IAT on a Jeep especially, when you put it in a colder location, the truck just runs so much better. Well, I'm not pulling an additional 1 to 2 to 3 degrees of timing. The same thing goes for ECT. Now ECT is not as bad, but on a Jeep you're going to see it's a lot worse. So I am pulling 2 degrees to 4 degrees of timing if it gets hot. So it's good to keep these two in that zone. Um, so basically what I'm going to do is I'm going to zero out these two. If it really does overheat, I'm going to leave it right where it's at and let it pull 4 degrees out so I don't pop my head gasket, when I see my temps raising. Now, as for ACT, I don't need it unless I'm in Yuma. You can zero out this wide open throttle column right here and keep this. If you're in Yuma, you can keep all this. Otherwise, you can take all that and zero your air inlet temp sensor out and not worry about the manifold heating it up and causing it to pull timing out. So now you can go down to your spark tables, and now this is where you can play with your tables here. So basically, back in the old days, from 2000 RPM on, we would set our distributor advances to whatever peak power. So for example, 30 degrees of timing, right? So basically, by 2000 RPM, I'm giving the engine 30 degrees spark advance, and I'm holding it all the way through. Let's say you went 34 degrees of timing on there, and then I rolled my timing, whoops, and then I rolled, oh, come on, rolled my timing back to 32 degrees, then to 30 to get more mile per hour on the top end. So that's how you would create your power on there. So basically what I do is, and I'll show you guys, this is a pretty simple spark curve I've been running forever, and I call it the 450 cam. So basically, same thing. When I'm key on, I crank with very low timing, so it keys on, cranks, and then I'm idling somewhere right around 15 to 14, right around here. Right about 14 is where I'm idling with it. I come out of the hole with 36. 36, I roll it back to 34, 32, 32, 32, all the way. So now I take this table, Control C, and I paste it into my other two tables. Control V and Control V. Okay, so there's a nice 93 octane spark curve in a decent cool area where there's not a lot of hot air temps going on. So if I wanted to make that a 91, I can take my ECT spark, whoops, not that one. I can return those back to stock. So now, for example, when I'm pulling 32 degrees of timing right here, if it is truly a hot day out, it's going to pull 3 degrees of timing, 2 degrees, 1 degree, 3 degrees, 2, 1 from that main spark table here. It's going to pull those timing numbers out. Let's say, for example, the guy wants to run a nice, he wants to run 87 octane. So I'm going to change these numbers right here to 28. So why did I change this 691 to match that? Well, because the map sensors sometimes don't make it to 787. Sometimes they only see 691. So I make that transition point at wide open throttle match on both of these two numbers right here. So you can see this guy, we can change this like to 3000 RPM, give him 30 degrees, and then I would take, copy, Control C, paste it into the EGR, paste it into the non-EGR, so all the tables are the same. I'm still pulling timing out right here, 2 here and 2 over in the spark retard here. So basically that's my base timing table right there for an 87 octane setup and flying here. So anyway, so there you go. That's pretty much how I do that. And then the way I do it, I mean, obviously a customer will email me their serial number on the back of their tuner if this is their truck. Then I can export it I can create an export for them, and it creates a CEF customer export file. I punch in the serial number here, and then I email it to them. I email the changes to them from there. So, but you can see that's a pretty simple setup for 87 and 93 octane. Can you go in there and change a whole lot more options? You can. You can go into your trans here, and I can bump up my trans line pressure PSI. Whoops, right here. I can bump those numbers up right there. I can change the converter lockup. I can tell it to lock up at a certain time. So when you're at drag racing on the track, you can have the converter lock up sooner for more horsepower, or if he's got a 4,000 stall converter in there, you can leave it off and let him go through that, and then maybe lock it when he's in third gear. You can change your shift tables, 3/4 shift tables, based upon that OSS RPM on the back of the transmission there. So I can delay that. So sometimes like you'll shift first and second and 5,500, and then once you go from there, it shifts like at 4,000. So you can change that in these tables, but it can be tough to mess with, because sometimes, like for example, this truck right here, I can put changes in this table here, and the guy will take it out and go, well, it didn't accept it. So sometimes it doesn't take it. And then the next guy with a different PCM number will go out and go, yeah, that worked great. So it's kind of hit or miss with what works on the trucks, and you try it, give it a shot, and then learn from there and move on. So there's not a whole lot more things to really go over here. When you get into, I can desensitize the misfire counter here. So if you got a camshaft in there and it's throwing the misfire codes every so often, we can desensitize this to an RPM, set this to an RPM that it's never going to look for that cam. And once you do that, then it'll keep you from having the misfire check engine light, which makes people think they have misfire in there, and they don't. It's just the loping of the cam and the timing of the crankshaft timing, going around pausing from 1 degree to 2 degrees to 3 degrees, and so it perceives that as a misfire. So there's so many more things in here we could go into, but that's basically the easiest way to show you guys how to do a simple SCT tune for what you're doing for your octane fuel. So that's why it's real important to have your octane of choice in there. So anyway, I hope you enjoyed this video. This is pretty cool. I'm finally getting my NCH software to work right here. I usually don't sit in the office here a lot. I answer emails in here, and I write my programs, and I get back out to the shop. So, but I hope you enjoyed this video, and if you're interested in that software, you can, and you've already bought an SCT, you can actually buy the dongle from me, and I can send you the software to register to it, so you have the exact same software here. And then that way you can make your changes on your own without having to worry about me, because sometimes I get overwhelmed with the emails here, and that way you don't have any problems. But as always, just shoot me an email at tech support on the website there, and I hope this helps, gives you guys some idea of where to start. Super easy setup. Can you go into a lot more detail? Absolutely. You can get on the dyno and you can dial that in. You can dial in your air-fuel ratio right there on the dyno, spark curve, spark knock, whatever you have. So I hope you enjoyed this. Take care and have a great day.